All right, today we're going to go over slope of lines, which if you remember last week, well, it was the day you guys got called out to go to the pack. We talked about slope just a little bit, right? Now, there's a lot of different ways that we can find slope. It depends on what it gives you as to how we do that. But does anyone remember other ways that we talk about slope? Or what other, there's another word for slope. Sometimes they call it something else. Does anyone know what it is? Well, slope-intercept form is a form of an equation, but there's another word that also means slope. Rate of change, right? So slope and rate of change are the same thing. Okay, and there's a few different ways that we find slope or rate of change. Can anyone tell me any of those ways that we can find slope or rate of change? What if we have a graph? The easiest way is to use what? We talk about it when we actually graph, right? We put the y-intercept on, and then we use our slope, but what two words do we help us to know which directions to go up and down and left and right?
Y and X and Y.
Rise over run. Yes. Right? Rise over run tells you to move up and down first, and then left and right. The other way sometimes we say specifically for rate of change would be the change in y over the change in x. So this method we kind of use when we have a graph, right? And it already gives you slope as a fraction. This method we tend to use when it gives you like a table of values, right? Something like this, x and y with numbers similar to this. Right? Okay, now, what about last week when we had two ordered pairs? How did we find slope? We talked about it just briefly. When we have two ordered pairs, does anyone remember? That's the equation, but not how we find the slope. Y2. Whew, come on, y'all. There we go. Over. Okay, this is going to be an important one for us today. Y2 minus Y1 over X2 minus X1. I can't remember if this class actually got too much of that or not. I might have in my other class because they were in here the whole time. Do what? What'd you ask? Okay, so this is the formula that we use mostly today when it gives us ordered pairs and asks you to find slope. Okay, we'll just subtract the two y values, subtract the two x values. Now, before we do that, I'm just going to remind you of the types of slope that we have. Okay. Okay, what type of slope does this line have just by looking at it? It's going up, so it's positive. Okay, the first two are usually pretty simple. We know this one would be what? Okay, then we have two types of slope that look like this. Straight line horizontal and a straight line going vertical. Does anyone remember, even if you don't know which one is which, do we know the two types of slope that are shown here?
One's 0 and one is...
You are correct. One is 0, the other is undefined. Okay, now, does anyone know which has a slope of 0 and which one's undefined?
0 the line that's kind of like
horizontal.
Yes. Now, the reason that is because 0 here, this would be like 0 divided by any number. Well, what's 0 divided by anything? 0. Undefined is some kind of number divided by 0. Can you actually divide a number by 0? It's impossible, right? It's impossible to take a number and divide it by 0, so that's why it would be undefined. Okay, do we kind of remember seeing this? Should have seen it last year in algebra, pre-algebra, same thing. Okay? All right, let's do a few examples. Anybody still writing this down? Okay, a couple of us. All right, example 1. We have two ordered pairs, 3, 6. Hey, are y'all wanting me to take extra time on this or what?
No.
It seems like it, as much as we're talking today.
I'm about to know what
Okay. When we're given two ordered pairs, all you have to do is y2 minus y1 over x2 minus x1. Now, the easiest way to do that is start with your second ordered pair. What's the y value in my second ordered pair? 2. And subtract the y value from your first ordered pair, 6. And then you just do that same thing with your x values. X value from the second ordered pair, -9 minus 3. Okay, and then we just use simple math. What's 2 minus 6? -4 over negative what? -12. Now, can we have a negative divided by a negative? No, so we know it's going to change to positive, and then we simplify. What would that simplify to? 2 over 6, which would be 1/3. You always want it in complete simplest form. Okay. Miguel, how would I solve for slope here?
slope.
Yep. 1 minus 1. Okay. 1 minus 1 would give us what? 0. What's -2 minus 3? -5. 0 divided by anything is 0. Okay, last one. Anybody want to take this one?
7 minus
Okay, 7 minus 3 over what, Jordy? -4 minus -4. Good. Make sure sometimes when when the number we're subtracting is a negative, we forget to put the double negative there. You can't forget to do that. Okay. What's 7 minus 3? 4. What happens to this double negative here? We change it to what? So -4 plus 4 would give you 0. We talked about what happens when we try to divide by 0. What do we get? Undefined. Yes, not unidentified. Undefined. Okay? All right. Simple enough on this, yes? Okay. There's one other thing we're going to talk about, and I'm going to let you go. Do what? Yep. Yeah, sorry.
What is our, like, we have decided,
It's in the book. What's up? Say that again. When you try to divide by 0, yeah, because you can't divide something by 0, so that's the only time it'd be undefined. Okay. All right, here we go. Okay, next part we're going to talk about is if I have parallel or perpendicular lines. Listen, I'm tired of having to talk over people today. And you guys know every time I do a lesson, I'm having to record. So me having to wait on you now goes in this recording because you guys can't just stay focused. Okay. Can someone tell me, if we're talking about parallel lines and referencing their slope, what would we know about the slope of two parallel lines? Say it again. Yeah, they're the same thing, okay? Right? So we know in order for two lines to be parallel, they have to have the same slope because that's what's going to keep them from ever crossing. Okay? Now, does anyone remember what we know about perpendicular slopes? True, but specifically, what do we know about their slope? Anybody remember it? Well, somebody give me some guesses. It can't be the same because then they'd be parallel. True. You're close. That's not the only thing. What do you mean by opposite?
Like, they don't.
Give me an example of two opposite slopes. Well, give me an example of two opposite numbers.
Up and down.
Okay, -3 and 3. So you're close, but that's not the only thing. They are opposite, so their signs do change. But what do we know typically about slope? It's written as a what? Fraction. What else would change about that fraction besides the sign?
The denominator goes on top?
True. Yes. That's called the reciprocal, right? So perpendicular slopes have opposite reciprocal. Okay, now an example of that would be like 4/5. What's the opposite reciprocal of 4/5?
5/4.
That's just the reciprocal. What's the opposite reciprocal? -5/4. So you flip the fraction, change the sign. Okay, what's the opposite reciprocal of -2? That's just the opposite. You have to flip that fraction also. Not 2/1, 1/2. Yeah. Whole numbers can be a little difficult because you kind of have to imagine this is -2/1 to start, and then we flip that for the other side. Okay? Now, here's why we have to know opposite reciprocal. Because, like, if I had a slope of -2 and then +2, are those two slopes going to be perpendicular? No, they're just opposites. If they're not opposite reciprocal, that doesn't work. Okay? So we're going to look at two examples, and then we'll be done. Yes. Okay, so let's say it asks you to determine whether or not these two lines that pass through these 2 points, so AB and then CD, are parallel, perpendicular, or neither. What would you need to find first in order to determine that? Slope. Okay, do we know how to find slope of line AB?
7 and 1.
Okay, so let's find slope of AB first.
7 minus 1.
7 minus 1, -2 minus 8. Okay, what is 7 minus 1? And -2 minus 8? -10. Now, again, we need to simplify this as much as we can. Both numbers are divisible by 2. What would that give you? -3/5. Okay, then all you have to do is the same thing for CD. So somebody else tell me, how would I find the slope of CD? -1 minus 2 over minus what? Minus -6. Okay, -1 minus 2, we get -3. What about negative 1 plus 6?
5.
Positive 5. Okay. What do I notice about those two slopes? Which means this is what type of lines? Parallel. Okay, I want you to try this one on your own.
Same thing?
Mm-hmm. Yep, we're going to determine if the two slopes are parallel, perpendicular, or neither. Okay, what we get? Did we get perpendicular?
Yeah.
Okay. You can check up on the board if you need to check your work. All right. Your assignment today is page 192.
Give us a worksheet, man.
Diego. Chill, bro.
Oh, yeah? I'll make sure.
Okay, listen. On today's assignment, everyone needs to listen to this because for whatever reason, every time we do a book assignment, people get confused. Okay? What's the first problem you're going to do?
2.
Number 2. What's the next problem? Then you skip to 12. Are you going to do number 13? You're doing 12 through 26B. 26 has like maybe a C and a D. You're not doing those, just A and B. And then 28 through 32.